In March of 1980, Mount St. Helens came to life with a magnitude 4.2 earthquake. Signs of an eruption showed, but geologists could not accurately predict if an eruption was certain due to the limited equipment and technology of the time. Then, on May 18th, Mount St. Helens erupted, tragically killing many people and wildlife. But over time, the disaster became a triumph due to advancements and innovations in predicting technology that later would save more lives.
Mount St. Helens. For 123 years it was dormant, but today the volcano exploded with a powerful force that turned daylight to dark.
Also known as Fire Mountain by the Cowlitz Indians, Mount St. Helens has been erupting for centuries. The last known recorded activity was 123 years before the 1980 eruption and lasted from 1831 to 1857. Although there aren't many recorded eruptions from the volcano, we have learned the mountain seems to erupt every 100 to 150 years, thus making it known as the most active volcano out of 18 in the Cascade Range.
Washington State produced an extraordinary outpouring of smoke and ash today. From a distance, it was an awesome and strangely beautiful sight, but up close was something else.
On the morning of March 20th, an earthquake of 4.2 hit Mount St. Helens. Geologists rushed to the mountain studying every earthquake that followed. By the 25th, it was estimated that about 3 earthquakes hit every hour. Then, on the 27th, the mountain released an ash cloud that created a crater 250 feet wide. Washington State Governor Dixie Lee Ray decided to limit access to the mountain, creating red and blue danger zones. Red zones were closed except to scientific researchers and law enforcement, while blue zones required a permit to enter. The decision was made not to extend the danger zones onto Weyerhaeuser property so loggers can continue working. The boundary between the National Forest and Weyerhaeuser property was only 3 miles from the peak, resulting in very thin red and blue zones. Unfortunately, scientists being consulted at the time were unsure of the dangers that were yet to come due to the limited technology and monitoring equipment.
We're not going to have a lot of warning if a final big eruption starts. I think probably a day is the outside.
And minutes on the inside?
Yeah, minutes, or it might happen without really telling us it's going to happen. It might just go.
Vancouver, Vancouver, this is it. Those are the famous last words of David Johnson before him and his trailer were wiped away at 8:35 a.m. David Johnson was a geologist that was observing the mountain from a close-up view. Although he feared staying the night, he stayed anyway, losing his life the next morning.
Later in the afternoon, went up to Coldwater 2, where David Johnson was, and delivered the distance measuring device to him. Eventually, he said, "You know, you're planning on spending the night up here and working on the volcano the next day, but this is really a hazardous place. Why don't you just drive back to Vancouver and then come back up here tomorrow? Let's have as few people here as possible." And so Mindy and I, and Harry Glicken as well in his own vehicle, we all left as the sun was setting. We heeded David's advice, and it's a good thing we did because it saved our lives. While we were driving back up to Mount St. Helens on Sunday morning, we watched the debris avalanche happen, and David was killed in that debris avalanche.
But this tragic eruption not only took Johnson, but also with a 5.1 earthquake caused the volcano summit to slide away, creating the biggest landslide in recorded human history. Mud and debris flew up to 13 miles away from the mountain and destroyed many square feet of forest, causing billions of dollars in damage. The lateral blast of hot material accelerated to at least 300 miles per hour and produced an ash cloud that rose more than 15 miles into the atmosphere. Avalanches of hot ash, pumice, and gas poured out of the crater at 50 to 80 miles per hour. Over the course of the day, 520 million tons of ash was blown eastward across the United States, causing complete darkness. Mud flows filled rivers with rocks, sand, and mud, damaging 27 bridges, 200 homes, and forcing 31 ships to remain in ports upstream. The volcanic ash cloud drifted east across the United States in 3 days and spread across the world in 15. Within 18 minutes after the eruption, first responders had shown up in helicopters searching for survivors. After many days of intense searching, 170 people were rescued and 57 people were declared dead or missing. Over 250 square miles of wildlife was now gone. The volcano had left a landscape of devastation and left many people in fear of what may happen next.
Somebody said it looked like a moonscape. But the moon looks like a golf course compared to what's up there. It is a horrible-looking sight.
The mountain had gone from one of nature's biggest triumphs to one of nature's biggest tragedies. Of the 57 people killed, only 3 were inside the danger zones, including Harry Truman, an 83-year-old man who famously refused to leave, and 2 others with permission to be there for research.
There was tragedy at Mount St. Helens. We lost 57 lives, including that of Dave. That was tragic. And I would hope that we would not lose that many lives again. The good part was that it really got our attention. It got the attention of scientists, got the attention of public officials, of the society in general. So it was a real wake-up call for us. So the big thing we learned, the biggest triumph from Mount St. Helens, is that we learned a big lesson. It got our attention.
Shortly after the eruption, many people started to help clean up all the ash. Newspapers' front pages were covered in stories about what was happening with the hunt for bodies and the ash cleanup. With the newfound attention to Mount St. Helens from the eruption, scientists from around the world started to study and learn from the eruption, making new discoveries and developing new monitoring techniques to better understand volcanoes so this wouldn't happen again.
We learned a lot about how you interact with the civil defense, with the public, with the press. As a result, I think volcanology took a quantum leap in science as well as applicability to society's needs.
As the years went by, geologists were learning more and more about volcanoes from the study of Mount St. Helens, including one mystery involving round-shaped mounds of rocks and debris from volcanic landslides known as hummocks. Geologists had seen these round mounds of rocks and debris before at Mount Shasta in California, but had not known how they appeared. After the 1980 eruption of Mount St. Helens, these hummocks appeared again. Geologist Harry Glicken decided to solve the mystery by visiting more than 675 hummocks. He discovered the rock making up the hummocks was the same as the rock that had made up the summit of the mountain before it slid off.
We see these hummocks around volcanoes all over the world, indicating this type of an eruption actually isn't as uncommon as we once thought.
With this increased knowledge of volcanoes, scientists began to test and develop many new innovative technologies, such as GPS, infrared imaging, acoustic flow monitoring, and Doppler radar. With these new technologies, they developed VDAP, also known as the Volcanic Disaster Assistance Program. VDAP is a program based out of the USGS Cascades Volcano Observatory in Vancouver, Washington. It consists of scientists that respond to volcanic activity across the planet. Since 1986, they have strived to ensure that such a tragedy like Mount St. Helens will never happen again by assisting in more than 70 volcanic disasters. One of VDAP's greatest success stories was the prediction of the eruption of Mount Pinatubo in the Philippines, where 35,000 military personnel and local villagers were evacuated just days before the 1991 eruption.
Greatest triumph was everyone being on board and learning as much as they could. So hopefully in the future we'll know what's going to happen.
Today, almost 39 years later after the eruption of Mount St. Helens, it is still evident to government officials and geologists that we can still improve monitoring to help save lives. On March 12, 2019, the President signed into law a bill called the National Volcano Early Warning and Monitoring System Act, co-sponsored by Washington State Senator Maria Cantwell. This bill provides legislation to strengthen existing monitoring systems and connect them into one united system.
Increasing the monitoring means deploying new sensors, seismometers, and GPS devices that are critical to detecting any kind of change on a peak that is now helping us determine what the exact threat level should be. It is this data that will help us save lives and to protect the communities that are most vulnerable. So, we definitely can't stop volcanoes from erupting, but we can put better tools in place to give the communities and scientists better data and information, and from that, our local communities can develop better communication and response plans.
When Mount St. Helens first started to rumble in March of 1980, scientists anxiously studied the volcano. Many months of intense studying went by, but on May 18th, scientists still lacked the knowledge and equipment to predict this tragic eruption. After the 1980 eruption, it seemed there was no hope left for the volcano. But as we watched the triumphant recovery, we were able to learn more about nature and make advancements in how we can predict eruptions. The new technology that we now have provides more preventative measures to evacuate before tragedy strikes, ensuring more lives are saved today, not only in Washington, but around the world.
It just goes to show that if you really feel strongly about something, if you feel others should know because it's going to save lives, you should speak up. If David did it, we all can. So.